Today, we're going to talk about how to put 32 3090s or 4090s in a single 42U server rack and how to ensure that you have redundant power to the servers as well as the ability to control your heat and scale this up. A big mistake that a ton of people make when they start to host consumer GPUs is they don't do anything to control the airflow, or they don't use a case at all, and heat just kind of escapes and goes everywhere in the facility. As you scale up your operation and you don't have control of where heat is, you end up with these hot spots that cause all kinds of reliability issues and can actually pose, a threat to your facility. So the chassis you see behind us, this is our solution. We got this from a company called One Chassis. They worked with us on, designing it and customizing it to how we wanted it. We wanted to use a 10U chassis because basically for power considerations, we didn't want to put more than 4 of these in a 42U rack anyways. At 4 of them with 4090s, you're looking at, I think, almost 16 kilowatts of draw at peak usage. And we wanted to basically run within a 20 kilowatt rack, and not go above that, right? If you go above a 20 kilowatt rack, that kind of density, you run into a lot of cooling challenges. So we use this 10U chassis. Inside it, we'd put 8 4090s. We use a motherboard from ASRock that would allow us to cable all of those back to it at PCIe X16. And then we'd use 10 gig NICs. So you see on the chassis here, there's 10 gig RJ45 ports right on the motherboard. And then you can see there's a slot there for a NIC, where in this case, this is in Canada, we were using transceiver-based networking. So I actually needed to add another 10 gig NIC to it. But all in, we would take the 4 of these, we'd put them all in a server rack. And then in the back of the rack to power it, it made it really convenient because we would just use 4 0U vertical, PDBs or PDUs, sorry, to distribute power. So each of those were 30 amp, 208 volt, and we could fit, the 4 chassis with the PDUs in the back of the rack, each connected to, one 1600 watt power supply in the back of each chassis. So each PDU powers one power supply on each chassis. That all feeds into the redundant PDBs inside the chassis. And we had a system where if any sort of component failed in that power delivery, we would actually still be able to run. So super effective way to build a full rack of consumer GPUs. And then using that as sort of a building block, you can scale that up and build pods where you've got like a cold aisle containment or a hot aisle containment. And it's all centered around this, this 20 kilowatt rack. So wanted to share the design that we used. This chassis is a total beast, like totally full. It weighs like 100 pounds. But it was honestly, I think, a really good solution for what we were doing. And actually, last detail, the GPUs actually all stay on one side of it. So this side of the chassis, there's a pretty large void right there. And then the GPUs are vertically stacked at the back. So all the cold air basically enters the chassis and it just crosses the GPUs, gets hot, and is immediately ejected. Whereas a lot of chassis use a design where, there's like GPUs and then GPUs. So air heats up over one set of GPUs and then goes over to the next set of GPUs, and you end up basically, putting hot air over your GPUs you're trying to cool. So I think it's a pretty cool design. I think a lot of people were curious about this, so I figured I'd make a quick video. See ya.